안녕! Welcome to KMS. This is the second video in our tricky functions series. Let's take a look at a rational function. Alright, here's the question we are working with. We want to find the equation of the tangent line using the definition of the derivative for the function fx equals 1 over x plus 2 at x equals 1. Let's do a quick sketch to help us visualize the problem. Let's find some key features to sketch the function. First, the vertical asymptote. A vertical asymptote occurs when the denominator becomes 0. In this case, the denominator is x plus 2. Set x plus 2 equals 0 and solve for x. So x equals minus 2. That's the 0 of the denominator. So we have the vertical asymptote at x equals minus 2. The horizontal asymptote. For a rational function, the horizontal asymptote is determined by the degree of the top and bottom. In the numerator, there's only a constant. That's the same as x to the power of 0. So, the degree of the numerator is 0. Also, we have x plus 2 in the denominator. So, the degree of the denominator is 1. Since the degree of the numerator is less than the degree of the denominator, so the horizontal asymptote is y equals 0. Now, let's find the point on the graph. I'm choosing x equals minus 1 because it's easy to work with. When we plug x equals minus 1 into the function, f of minus 1 equals 1 over minus 1 plus 2, which equals 1 over 1. That gives us 1. So the graph passes through the point minus 1, 1. Let's plot that point right here. So the graph on the right side looks like this. Let's find the symmetry point. This type of rational function, which is constant over linear, is symmetric about the point where the vertical asymptote and the horizontal asymptote intersect. So the graph is symmetric about minus 2, 0. From this point, 1 unit to the right and 1 unit up, that gives us the point minus 1, 1. Also from this point, 1 unit to the left, 1 unit down, that means the symmetric point is minus 3, minus 1. So the left side of the graph should look like this. Alright, now that the graph is done, let's focus on the actual question. What we want to do is find the equation of the tangent line at x equals 1. To do that, we need two things. First, the slope of the tangent line. Second, the point of tangency. Let's start with the point of tangency. The point of tangency is the point where the tangent line touches the curve. In this question, we are given x equals 1. f of 1 equals 1 over 1 plus 2, which equals 1 over 3. So, the point of tangency is 1, 1 over 3. Right here. That's exactly where the tangent line touches the graph. Now, let's try to find the slope of the tangent line at this point. The slope of the tangent line. We write that as f prime 1. We will use the definition of the derivative, which is also called the first principle. And this is defined limit as h approaches 0, f of 1 plus h minus f of 1 divided by h. f of 1 plus h, just replace x with 1 plus h. When x equals 1 plus h, f of 1 plus h is 1 over 1 plus h plus 2, which equals 1 over 3 plus h. So, the expression becomes limit as h approaches 0. f of 1 plus h is 1 over 3 plus h, 1 over 3 plus h minus, and also f of 1 is 1 over 3, 1 over 3 divided by h. To simplify this expression, let's focus on the numerator for a second. We have 1 over 3 plus h minus 1 over 3. To simplify this, we need a common denominator. Let's get a common denominator by multiplying these two. So, for the first fraction, multiply by 3 over 3. And for the second fraction, multiply by 3 plus h over 3 plus h. Just be careful. This negative is for the whole thing. Then it becomes 3 minus 3 plus h divided by 3 times 3 plus h, which is 3 minus 3 minus h over 3 and 3 plus h. 3 and minus 3 cancel out, and now the expression is minus h over 3 times 3 plus h. Now, we just plug the simplified form into the expression. Then it becomes limit as h approaches 0 minus h over 3 times 3 plus h over h. If we plug in h equals 0 right away, the numerator is 0 over 3 times 3, which is 0. And the denominator is also 0. So we get 0 over 0, which is an indeterminate form. That means we need to simplify this expression further. To do that, let's think about this expression. A over b over c over d, which is the same as a over b divided by c over d. When you see division, you just change it to multiplication and flip the second fraction. Now we have a over b times d over c, which becomes ad over bc. To go from here to here directly, you just multiply the very top and very bottom, ad, over the middle two, bc. Let's apply this idea to our expression. The denominator h is actually h over 1. So the expression becomes limit as h approaches 0, multiply the very top and the very bottom, minus h times 1 over, multiply the middle two, 3 and 3 plus h and also times h. Now we have h on the top and bottom, so we cancel them out. Then the expression becomes limit as h approaches 0 minus 1 over 3 times 3 plus h. Now plug h equals 0. That gives us minus 1 over 3 times 3, which is minus 1 over 9. That means the slope of the tangent line at x equals 1. Now we are ready to write the equation of the tangent line. Let's use the slope-intercept form. Y equals mx plus b. We know the slope is minus 1 over 9. So the equation is y equals minus 1 over 9x plus b. And the point of tangency is 1, 1 over 3. Let's plug this point into the equation. So 1 over 3 equals minus 1 over 9 times 1 plus b. Let's move minus 1 over 9 to the other side. 1 over 3 plus 1 over 9 equals b. 1 over 3 is 3 over 9. So b equals 3 over 9 plus 1 over 9, which is 4 over 9. Therefore, the equation of the tangent line is y equals minus 1 over 9x plus 4 over 9. That's it for today. I hope this helped. 안녕. See you in the next video.